All right, boys and girls, welcome back to Drive Through for a little 5-minute lesson. Here we are. We're going to go through the 5-4 interactive lesson and learn about inequalities of a triangle. So, if we were back in the day, we didn't have so many computers and so much freedom. We would cut out straws, and you guys would actually experiment with this. And you'd learn. Like, this was a really good lesson. Okay, back when I taught every single day. So, what you would find out by just a very quick experiment is if you tried to make a triangle out of a 10 and a 2 and a 4, you would be stuck. It would not make a triangle. These two things would spin around. You could spin them around as much as you want, and they would never touch each other because 2 plus 4 is not as big as 10. However, if let's say you wanted to make a sweet triangle and you picked 10 and 6 and 7, that would work no problem, okay, as I choose numbers from these straws, because 6 plus 7 is more than 10. So what this is explaining to you is what's called the triangle inequality theorem that says in any triangle, the sum of the smaller two sides must be bigger than the third side. So what if they told you that the sides were 6 and 7, and they asked you to find the missing side? Sorry, Nathan, just trying to annoy this out of existence so we can pick a new fad. So anytime an adult jumps on it, it'll end it. This is great. It'll be over before winter break gets here. So what would be the possible lengths of the missing third side? The missing third side x would have to be bigger than 1 and less than 13. How did I get that? Well, if 1 was the smallest side, 1 plus 6 would have to be bigger than 7. And if x was the biggest side, it would have to be smaller than the sum. So that's an important set of questions. Whoops. Boink. Next slide. Okay. How are side lengths and angle measures related? Well, since it's a 5-minute lesson, I'll just tell you. The biggest angle is always across from the biggest side. And the smallest angle in a triangle is always across from the smallest side. Notice that in this triangle, 6 and 6 are the same length. R and Q are the same measure. You already knew that, isosceles triangles. Hey, what you can do with these interactive is you can play around. Let's have some fun. Look. Oh, man. Oh, I could do this for days and just see what's happening. But look, now this is the longest side because this is the biggest angle. But now this is the longest side because this is the biggest angle. Interactive. Who needs straws? You know, especially plastic ones. That's kind of a joke. I'm not a big fan of paper straws. Okay, if two sides in a triangle are not congruent, then the larger angle lies across the longer side. That's what we just talked about. This is in theorem words. Let's see what else they got for us. If two angles from a triangle are not congruent, then the longer side lies opposite the larger angle. That seems like the converse of the last one. It is. We're not going to go through the proofs. Next. Which side? Oh, this is just practicing it. So this is a pretty simple example. We'll go through it real quick. Let's use our math skills. The sum of the triangles, some of the angles in a triangle are 180. So if I did 180 minus 112, what do I get? 68 for this one? Is that right? Did I do that right? Oh, geez. 68 and 62 is 130. Yes? So that means the longest side must be LM because it's across from the biggest angle. Boink. 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 The sum, okay, so this is what A plus B has to be bigger than C, A plus C. The sum of the two smaller sides must be bigger than the third side. And here's your summary. That was a quick one. Do we have anything else to do? Nope, now we're on to practice. Okay, hope this helps. Boom!